So we have a question here where we have to solve the system of linear equations. So we have three equations which have three variables. So essentially, we have to find the values of x, y, and z using a system of linear equations. So what we're gonna do is we're gonna take equation one and two, and then we will try to eliminate two variables and see what are we able to get. So I'll take the first equation, which is 3x minus y plus 2z equals to 16, and the other one is x plus y minus 2z equals to negative 12. Now, in this part, what we would have tried to do was to eliminate one variable. But in this equation, I guess this is like a very unique case where we were able to eliminate two variables in a single step. So that just leaves us with, because there's a plus sign, so that leaves us with 4x equals to 4 and x equals to 1. This is just one type of a problem that you might face in the system of linear equations. You might not be able to cancel out two variables in a single step. You might have to you might be able to cancel one variable, leaving behind two other variables, and then you repeat that with the other equation, and then take these two equations and then try to eliminate that variable. But if we do have that problem in the future, I'll try to post a video for that as well. So now that we know that x is equals to 1, what I can try to do is, if you notice in the third equation, we have 7x plus 3y equals to minus 2. We already know the value of x, so all we can do is we can just plug in that value of x, which is 1, and we can solve for the value of y. So 7 plus 3y minus 2, leaving behind minus 2 minus 7, so that leaves me with minus 9, and that will give me minus 3. So now we have x and y value. Now the problem is basically solved. Now all we have to do is either I can plug into the value of x and y either in equation 1 or equation 2. So let's just try to pick an equation that's easier for us to calculate the value of z. So I'll plug it into the equation 2. So that will give me x is 1. So I'll plug in x equals to 1 and then plus y, but y is negative, so that would be negative 3 minus 2z equals to negative 12. 1 minus 3 will give me minus 2. Minus 2z equals to negative 12, negative 2z. So I'm going to move this negative 2 over, so it becomes negative 2 plus 2, leaving behind minus 2z equals to 10. Negative, cancel each other out, leaving behind z equals 2, and then we'll move the 2 or divide 2 on both sides to solve for the value of z, so that will give me 5. So as you can see, I got my value of x is 1, y is negative 3, and z is 5. Now, in order to check if your answer is correct, what you can do is simply plug in these three values in one of these equations and then just compare what you get on the right hand side. Is it equal to the right hand side or not? So let's try to check it with the equation number 2. So since x is equals to 1, and by the way, I'm just plugging into equation 2. So x is equals to 1, y is negative 3, and negative 3, sorry about that. Let's make it neat. Okay, negative 3 and then negative 2z. Z is 5, negative 12. So 1 minus 3 is negative 2, and minus 10 minus 12 is equals to minus 12. So that essentially is kind of like a verification step that the left hand side is indeed equal to the right hand side. So that is it for this type of problem. If I have any other problems, I'll try to post some other different kind of like unique cases too. Thank you.